Hi everyone, welcome back to ChemHelp ASAP. In today's video we are going to talk about solubility rules. Now these apply to ionic compounds that are either soluble or insoluble in aqueous solutions. So in other words, we're going to figure out what salts, i.e. ionic compounds, will dissolve in water and make aqueous solutions. Let's get started.
First, let's talk about our solubility rules. So this table right here gives us our basic rules for determining if salts are soluble or if salts are insoluble. So let's start with the top of the table up here. These are for mostly soluble ions or mostly soluble salts. So you can see in my first row here, your alkali metals, here are all your alkali metals, remember they all have a +1 charge, and ammonium are going to be soluble. Now, in this right-hand column here, we have our exceptions, and you can see there are no exceptions. So any salt that, say, contains lithium is going to be a soluble salt. So we can say the same thing for a couple of anions down here. So for nitrate and acetate, you can see there are no exceptions, meaning any salt that contains the nitrate anion is going to be a soluble salt. Okay, so our first two rows are soluble salts with no exceptions. Now let's go on to our next row. So you can see these are our halogens here. They're not all the halogens, but they're some of the halogens. So any salt that contains these halogens are going to be soluble, except this time we do have exceptions. So if you are silver, mercury, or lead, then you are not going to be soluble. So these are the exceptions, meaning that most salts with these anions are soluble, except for your silver, mercury, and your lead. So for example, your lead iodide will not be soluble. Okay, for our last of our soluble ions, let's talk about sulfate right here. So again, your sulfate salts are generally soluble, but we have some exceptions. Here are our exceptions. So again, lead, calcium, strontium, and barium are exceptions to the soluble rule, meaning that if you have barium sulfate, that is going to be an insoluble salt. Okay, so that is the first part of the table, the soluble ions. Now let's talk about the lower half of the table right here. These are mostly insoluble, so these will not dissolve in aqueous solution. So your hydroxides, as a rule, are insoluble, except there are exceptions. So your alkali metals are all going to be soluble, and you can see how this exception ties into your solubility rule up above. So there are connections between all of our rules. Again, your calcium, strontium, and barium are going to form slightly soluble salts. Continuing on with our insoluble ions, we have sulfide right here. Again, mostly insoluble, but your exceptions, again, are going to be your alkali metals, your ammonium, and here you have your calcium, strontium, and barium. Your carbonates, again, mostly insoluble, except for your alkali metals and your ammonium. Your phosphate salts, again, same deal, mostly insoluble, except for your alkali metals and your ammonium cation. So that is a very brief overview of the rules of solubility, but of course, we want to be able to take these rules and apply them to actual salts. So let's do some practice with our solubility rules. Okay, so on this slide, I have kept up our solubility rules here on the right-hand side. And what we're going to do is we're going to take all of these different salts on the left-hand side and we're going to determine if they are soluble or not. Starting with our first salt, sodium chloride. So what I like to do is I like to take the salt in question and I will first identify the cation and the anion. So for sodium chloride, my cation is my sodium cation and my anion is my chloride anion. Next, I go to my rules and I see if I can find either my cation or my anion. Well, right off the bat, I see my cation right here. It is under our soluble ions, and there are no exceptions, which tells me that it doesn't even matter what the anion is. This is going to be a soluble salt. But specifically for sodium chloride, we could also look at the anion. So maybe you saw the anion first, right here. Again, chlorides are mostly soluble salts, and we want to make sure that we don't see sodium in our exceptions. So sodium is not part of our exceptions. So this is a soluble salt. Now, when a salt is soluble, especially if we're writing a chemical equation, what we do is after the molecular formula, we write an AQ. That stands for aqueous, meaning that this salt will dissolve in water, forming an aqueous solution. You are probably already familiar with some other state designations. Maybe I'll just put these at the bottom. So an S stands for a solid. An L stands for a liquid. A G stands for a gas. And now you know an AQ stands for aqueous. Again, so anytime we have a soluble salt, we're going to write AQ afterwards. If we have an insoluble salt, we will put an S afterwards, meaning that it is just a solid sitting in a liquid. Let's take a look at our next salt. Our next salt is calcium sulfate. Again, I'm going to break this up into my cation and anion. So we have our calcium cation and sulfate is our anion. I'm going to check my rules. I'm going to see if I can find either the cation or the anion, or again, like we saw with sodium chloride, sometimes you find both. So looking for calcium, I'm not seeing anything that jumps out at me in the left-hand column. So I'm going to switch over to my sulfate and see what I can find there. So yes, I definitely have a rule for my sulfate, so I'm going to use that. Sulfate is a mostly soluble salt, so let's make sure that calcium is not an exception, and calcium is an exception here. So that means instead of sulfate giving us a soluble salt, calcium sulfate is going to give us an insoluble salt. So we are going to use our S designation here to indicate that calcium sulfate is insoluble. On to the next salt, magnesium hydroxide. Again, I want to identify my cation, which is magnesium, and my anion, which is hydroxide. Let's see what my table tells me. I'm not seeing magnesium in the left-hand column here of my rules, but I am seeing hydroxide. Okay, so note that hydroxide is now under mostly insoluble salts. So our hydroxides are generally going to be insoluble unless we have an exception here. So I'm going to look over to my exceptions and see if I see magnesium anywhere in here. And I do not see magnesium. So magnesium is not an exception, meaning magnesium hydroxide is an insoluble salt. So I'm going to put an S after magnesium hydroxide. On to lead nitrate. So I have a lead cation and nitrate is my anion. Let's check the table. I do see lead, but it is over here on the right-hand side, so I'm going to hold off and see if I can find nitrate. Ideally, I want to find either my cation or my anion in my left-hand column, and then look at the exceptions in my right-hand column. Okay, so my anion is nitrate. I do have a rule for nitrate. So nitrate salts are soluble. Let's take a look at the exceptions. And in this case, there are no exceptions. So it doesn't matter that we have lead nitrate. All nitrate salts are soluble. So that means I'm going to put an AQ right here. This is one of those situations where if you had jumped to your, so you can see lead is right here as well. If you had jumped to your exceptions right away and you hadn't checked your anion, you might have marked this as insoluble. Again, this is why I like to try and find either my cation or my anion in my left-hand column first. Aluminum phosphate. So we have our aluminum cation and we have phosphate as the anion. Let's see what I can find. I'm not seeing aluminum on my left-hand column, but I am seeing phosphate way down here at the bottom. Okay, so phosphate is under a mostly insoluble salt. Let's see if aluminum is an exception. So my exceptions for my phosphate are only my alkali metals and ammonium, which aluminum is definitely not a part of. So aluminum phosphate is going to be an insoluble salt. So there is its S. Silver chloride. So silver is my cation and chloride is my anion. I'm not seeing silver in my left-hand column. I am seeing silver a little bit here in my right-hand column, but first let me check, see if my anion, my chloride, is in my left-hand column, and yes, it's right here. So I have a rule for chloride salts. Chloride salts are mostly soluble. Let's check the exceptions, and you can see I've already underlined. Silver is an exception to that. So most chloride salts are soluble, but in the case of silver, this is going to be an insoluble salt. Silver chloride is kind of one of those classic insoluble salts. You will probably at some point in your life do a lab where you precipitate out silver chloride. Okay, barium sulfate. Barium is my cation. Sulfate is my anion. I do see barium a couple places, but this is again all on the right-hand column. I want to check the left-hand column and see if I can find a rule. And I do have a rule for my sulfate, so I'm going to go to that one. So most sulfate salts are soluble. Let's see if barium is an exception. Yes, barium is one of my exceptions. So instead of this salt being a soluble salt, it is an insoluble salt. So this is also a solid. Strontium sulfide. So I have strontium as my cation and sulfide as my anion. So looking around, again, I do see strontium a little bit on the right-hand side, but let's check the left-hand side. Not seeing strontium. But I see sulfide right here. So I have a rule for my sulfide. These are mostly insoluble salts. Let's see if strontium's an exception. And yes, strontium is an exception. So instead of this being an insoluble salt, it is a soluble salt. So I'm going to put my AQ after my strontium sulfide. Potassium carbonate. So I have potassium as my cation and carbonate as my anion. Let's see what I've got. I do have a rule for potassium. It is a mostly soluble salt. Let's see if there are any exceptions. There are no exceptions. So this is automatically a soluble salt. So I can put an AQ here. Now, if you wanted to, you could also find carbonate. So you can find carbonate down here. It is under the insoluble salts. But if you look at the exceptions, there is potassium right there as one of our exceptions, meaning this carbonate is not insoluble. It is soluble. Next up is ammonium sulfide. We've seen sulfides before, but let's go ahead and identify our cation, which is ammonium, and our anion, which is sulfide. I'm already seeing a rule for ammonium. It is a soluble salt with no exceptions. So this is going to also be a soluble salt. But you can also check the anion. So here is sulfide. It's a mostly insoluble anion, but you can see the exception here is ammonium. Last example, nickel carbonate. So nickel is my cation. Carbonate is my anion. I'm not seeing nickel here in my left-hand column. Let's see if I can find carbonate. Here's carbonate right here. Okay, so carbonate is a mostly insoluble salt. Let's see if nickel is one of my exceptions. And no, nickel is not in any one of my exceptions. So this is an insoluble salt. So hopefully now you don't just understand the rules, but you understand how to apply the rules. Now let's talk about solubility of other types of compounds, because of course these are all ionic compounds. Let's see how covalent compounds behave. So our general rule for if things will dissolve in each other is the rule like dissolves like. Now this sounds very confusing at first, so let me clarify a little further. What I mean is that polar compounds are soluble in polar solvents, and nonpolar compounds are soluble in nonpolar solvents. So this is a way where we can determine if, say, a covalent compound is soluble in a particular solvent. Let's put this rule in application and work some examples. Okay, so I've got a table here. What we're going to do is we're going to take all of these different compounds here on the left-hand side, and we're going to decide if they are going to dissolve in water, which is a polar solvent, or if they're going to dissolve in benzene, which is a non-polar solvent. Just a side note, benzene is toxic. Please do not try and dissolve anything in benzene, but it is a fantastic non-polar solvent. Just like on our previous slide, we're going to start with table salt because it's something we all know and are familiar with. Yes, this is an ionic compound. I promise we will do covalent compounds. So table salt is sodium chloride. Is that a polar compound? Well, yes, absolutely, because you form a cation and an anion. This is about as polar as you get. So table salt will dissolve in water. It will not dissolve in benzene. Let's stick with materials that you're more comfortable with. Let's talk about olive oil. So even though you may not know the molecular formula of olive oil, I want you to think back to hopefully some kitchen experience. Could you dissolve table salt in olive oil? And the answer is no, you cannot. So if they do not dissolve, that means olive oil must be nonpolar. So if olive oil is nonpolar, will it dissolve in water? Again, you may have experience with this. Do oil and water mix? No, they do not. So it will not dissolve in water. But will it dissolve in benzene, which is nonpolar? Oh yes, absolutely. Now we get some molecular formulas. So let's take a look at ammonia. If you don't happen to remember off the top of your head if ammonia is a polar or a nonpolar molecule, it can be helpful to draw the Lewis structure and remember the shape of ammonia. So here is the Lewis structure, and remembering back to your molecular geometry, your VSEPR, this is a trigonal pyramidal structure. It is polar. Okay, so let me write polar down here in my table as well. So if ammonia is polar, will it dissolve in water, which is also polar? Yes, it will. Ammonia being polar, will it dissolve in benzene, which is nonpolar? No, it will not. Now let's go on to another molecular formula, CH4, which you may know as methane. Again, if you do not remember if this is a polar or nonpolar substance, let's draw the Lewis structure. So here is your Lewis structure for methane. This is a tetrahedral molecule, which means it is nonpolar. So let's write nonpolar by methane. So methane being a nonpolar molecule, will it dissolve in water, which is a polar solvent? No, it will not. But will it dissolve in benzene, which is a nonpolar solvent? Yes, it will. Next up, we have another salt, potassium phosphate. Again, this is a very polar compound because it's going to form a cation and an anion. And remember, your potassium salts are always soluble. But what are they soluble in? They are soluble in water, which is a polar solvent. So will potassium phosphate be soluble in benzene, which is a nonpolar solvent? No, it will not. Okay, next up, we have ethane. Now, ethane is one of those molecules that we call hydrocarbons, meaning that this molecule is comprised entirely of carbon and hydrogen. Now, let me give you a really quick and easy shortcut. All hydrocarbons are nonpolar. So if you have any compound that is comprised of simply carbon and hydrogen and nothing else, then it will be nonpolar. So you don't need to be able to name it. You don't need to know what it is. If it's just carbon and hydrogen, it's going to be nonpolar. So ethane, a hydrocarbon, which is nonpolar, will it be soluble in water, which is polar? No, it will not, but it will be soluble in benzene, which is also nonpolar. Benzene itself is also another hydrocarbon, which is why it's a great nonpolar solvent. Now let's take a look at our last example. This is butter. Again, you have some experience with butter, hopefully in the kitchen. I'll give you another hint since we just talked about hydrocarbons. Butter is made up of many hydrocarbons. So in that case, it is going to be nonpolar. But you could make other inferences as well. Again, if this was a question on a homework or a test. If you melt butter and olive oil together, do they dissolve? And hopefully you say, oh yeah, those do dissolve together. But if you melt butter and add table salt in, which is very polar, does the table salt dissolve? No, the table salt does not dissolve. Or you could also think, if I melt butter and mix it with water, does the water dissolve the butter? No, it does not. Which again means that butter is nonpolar. It's much happier dissolving in benzene. Although again, with all of these cooking things, do not use benzene in your kitchen. It is highly toxic. This is merely just to illustrate a very good nonpolar solvent.
While most people think of salts as always being soluble in water, we have seen that no, not all salts are going to be soluble in aqueous solution. Now, you might have experienced an insoluble salt just in your home. If you have a tea kettle that you use regularly, you might notice a white solid that builds up at the bottom of the tea kettle. Some people call this scale. Actually mostly calcium carbonate, which is an insoluble salt. Now I'll give you a hint, a little bit of vinegar will clean that up right away, but I'm not going to talk about acid and base chemistry now. We'll save that for another video. Thanks so much for watching.